Okay, so this density parameter is looking really good so far as a predictor of whether something will sink or float. Now I've got a second test to try, and this time I have 3 different samples of wood, each with a different density. Now I weighed each piece of wood and I measured the volume and I calculated the density. So the densities I have are from the lightest to the heaviest, 0.017 pounds per cubic inch, 0.030 pounds per cubic inch, and 0.047 pounds per cubic inch. The density of water is about 0.036, so somewhere in between Paducah and Cocobolo. So if this density parameter makes sense and it works, then that would say this Cocobolo wood, which is denser than water, should sink. So, shall we try it? Ready, steady, go! And it sinks. However, both of these samples ought to float in water. So, shall we try it? This is medium weight and this is the lightest weight or lightest density. So, ready, steady, go! And you can see they both float. But the lighter one, if you can tell, seems to float a little bit higher in the water than the slightly denser one. So this one, the Paducah, which is closer to the density of water, floats a little lower in the water. So let's do one more test, and that's going to be a flotation race. So I'm going to hold both of these specimens down at the bottom of the tank. Which one do you think will pop to the top fastest? The lighter density Aspen or the heavier Paducah? Well, let's test it. Gotta get a grip on my specimens. Okay, ready, steady, go! And the Aspen won the race. So density is not only a predictor of whether something will sink or float, but it also tells us how well it will float. Make sense? So I think we have a winner with density.